Welcome to Geometry. This is Chapter 13, Section 1, the tangent ratio. First, we got a couple warm-up questions here. In number 1, it says find the value of x in the given figures below. The first one, we have a triangle here. We've got angle 56, angle 82, and then here is x. So it looks like what we're going to do is use triangle sum theorem, and we're going to add those angles together and set them all equal to 180. So what would these add up to? 138 plus x equals 180. We're going to subtract 138 from each side, and we're going to get x is 42 degrees in this triangle. All right, in the other one, notice angle x that we're looking for is now outside of the triangle. We have the other two angles in the triangle, the remote interior. And if you remember the exterior angles theorem, it says this exterior angle x is equal to the two remote interiors. So that would be the angles not touching x down here. So if we add together the 40 and the 66, our angle x is 106 degrees. Okay, in the second warm-up, we got a triangle with sides of 8, 15, and 17 inches. They're asking us, is it a right triangle? If it is a right triangle, it will have a hypotenuse. The hypotenuse is always the longest side, and that is always represented by c in a squared plus b squared equals c squared. So what we're going to do is add 8 squared and 15 squared and see if it is equal to 17 squared. And 8 squared is 64, 15 squared is 225, and 17 squared is 289. If I add these two together, yes, 289 equals 289. We do have a right triangle. All right, let's get into today's lesson. First, it says investigate a ratio in a right triangle. Remember, a ratio is just a fraction. It's going to have a numerator, and it's going to have a denominator. When we think about a triangle in general, it has 3 sides. A right triangle will specifically have a hypotenuse. So let's look down here at this triangle ABC. I've got hypotenuse. AC is always the hypotenuse no matter what. Now I've got 2 other sides here labeled adjacent and opposite, and these can change based on what angle we're taking the perspective of. So let's look over here at part A. It says, where is AB in reference to angle C? So angle C is down here on the right, and side AB is over here. Notice it is across the triangle from angle C, so we can call side AB the opposite side. So let's write that in here for part A, opposite. And now it says we're still at angle C here. Where is side BC? Well, we know AC is always the hypotenuse. The opposite side is across the triangle. Now the other leg, the leg that's touching angle C here, would be our adjacent side. Adjacent side. Now part C we've kind of already answered. What part of the triangle is side AC? That's the hypotenuse. Okay, let me drag these off of here. Now the next 3 questions here are now in reference to angle A. So now we're up here at angle A. And it says, where is AB in reference to angle A? Well, here's angle A up here. Side AB is the leg that's touching angle A. So that's going to be the adjacent side. Adjacent, might as well write that in. Now part E, where is BC in reference to angle A? Well, here's side BC, and it is across the triangle from angle A. So side BC is the opposite side. Again, the hypotenuse is always the hypotenuse. The adjacent and opposite legs will be a matter of perspective from what angle you're at. And then part F, one more time. What part of the triangle is AC? That's the hypotenuse. And there we go. Okay, here in example 1, it says use the space below to complete the following. I'm going to do it on the next slide. Use a protractor, draw a 35-degree angle, label the vertex Z. So here's my protractor. I'm going to set it to 35. There we go. Put it right down here at this vertex. And then I'm going to draw a side coming out of there at 35 degrees. That'll work. Oops. Now we're going to label that vertex down there Z. Place point Y somewhere on one side of Z. I'm going to do it down here at the bottom. There's my point Y. Right on the horizontal side, it'll make the next step a little easier. Construct angle Y at 90 degrees. So back with the protractor, put it right about here, set it to 90. And take a line, go all the way up till we hit the other line. I think I'm done with the protractor. Get that out of the way. Extend the sides till they intersect. Label that X, and then we're going to measure a couple sides. So this up here is X, and we're going to measure, oops, wrong way, XY and YZ. YZ is at the bottom. That's the easier one. I have a metric ruler here. It looks like I should be pretty good. So let's see this side. If we're talking centimeters, I'm going to call that about 8.7. ZY is 8.7 centimeters. ZY, 8.7. And now we need XY. So that I'm going to have to rotate. And we're going up here. Get out of the way. And that looks like about 62 millimeters, so 6.2 centimeters. So if we set up a ratio here, a fraction, I want XY up top, 6.2 divided by 8.7. And here's my calculator. So we're going to do 6.2 divide 8.7, and we get about 0.71. So that's approximately 0.71. What relationship exists between your triangle and every other triangle in the classroom? Well, if we go back to the picture, this was set at 35. We made that happen. And then angle Y, we created a right angle there, 90 degrees. So we have angle, angle, triangle similarity. All the triangles drawn in the classroom today for this part are all similar. All S-I-M-I-S, similar by angle, angle, triangle, similarity theorem. Although everyone had different side lengths for their triangles, what did you notice about the ratio of the side lengths? All are the same, or they should be close, depending on how you did your angles and measured your sides. The more accurate, the better. If they should all be about the same. Okay, there's example 1. Now just a quick fill in the blank in the notes. The ratio that you calculated in that example 1 is called the tangent of angle Z. That can be abbreviated tan. Tan of Z. So the tangent ratio, our definition, the tan of angle A is the length of the side opposite angle A divided by the length of the side adjacent to angle A. So if we want to shorten that up, we can just write tan of A equals opposite over adjacent. A little mnemonic trick to memorize it, just T-O-A, TOA. Tangent is opposite over adjacent. So here in our second example 1, they're asking us to just find some tangent ratios. So find the tangent from angle theta in the given triangle. So I'm going to write tan of theta equals, and here is angle theta, and tangent is the opposite side over the adjacent side. So that'll be B divided by A. Now in part B, it says find the tangent of 90 minus angle theta. Well, remember, here we got a right triangle, so there's 180 degrees. This angle took up 90 of those degrees. This angle theta took up some more, but whatever's up here has to be what remains, 90 minus theta. So now we're just here at a different perspective, a different angle in the right triangle. Oops, it's supposed to be a theta. So the tan of 90 minus theta, it's still opposite, but now the opposite side is A. The adjacent side is B, A over B. Notice it's just a reciprocal of what we found up here. We did not use the hypotenuse at all in any of these calculations. Example 2. Now we got some actual numbers on our triangle. So I'm going to go back to red ink and let's do the tan of angle B first. Tan of B equals, here's angle B. Tangent is the opposite side, is 16, over the adjacent side, 5. Now we're going to hop over to angle C's perspective and do the tan of angle C. Tangent is still opposite, but now the opposite side is 5. Adjacent side is 16. 5 over 16. Notice again the 16.8, we didn't need it. If we wanted to find these as decimals, the first one, 16 over 5, is 3.2. 5 over 16 is 0.3125. And there's our tangents, opposites over adjacents. All right, now in this one it says, draw an isosceles right triangle. Oops. So here's my right angle, and then this is going to be the hypotenuse, and I'm going to mark these congruent. Now remember our isosceles triangle theorem, across from the congruent sides are congruent angles. So these two angles have to be the same. And if there's 180 degrees to go around and we use 90 in the right angle, that means there's 90 degrees left, and that will be evenly split between the two remaining angles. So each of these are 45 degrees. Okay, I guess that was part B. Calculate the measure of each angle in the triangle. And then it says use your drawing to compute the tan of 45 degrees. Now, you know, these sides, we did mark them congruent. We could put in any number we want there, or we could just keep it a generic x. This side is x, this side is x. So it doesn't matter what 45-degree angle I'm at. If I'm up here, my opposite side is x, my adjacent side is x. If I go to the other 45-degree angle, the opposite side is this x, and the adjacent side is the other x. So our tan of 45 is something divided by itself, and that is equal to 1. The tan of 45 is equal to 1. Now in example 4, just a little calculator work. Use a calculator to estimate the value of the following. I have a calculator right here. And I'm going to go into the trig setting, and here is my tangent button right here, tan. And we're going to make sure we're in degree mode here. Degree mode, if I click it, it turns to another angle measure, radian. We want to make sure we're in degree. So now I'm going to type in 51, trig, hit the tan key. And there's our output. We usually round these traditionally to 4 decimal places. So 1.2349. 1.2349. Up next, tan of 82. 82, trig, tan, 7.1154. 7.1154. Next up, tan of 19. 19, trig, tan, 0.3443. 0.3443. And now we're going to do the last one, the tan of 5 degrees. 5, trig, tan. And we get 0.0875. 0.0875. Now, if we notice here, you know, our angles got bigger from 5 to 19 to 82 to 51. And our tan values got bigger and bigger and bigger. Now it's time for some practice problems, so a good time to pause the video, try these problems, then fire the video back up and see if you got them right. All right, here in the first one, it says use the triangle at the right to find these. So the tan of 53, here we are at the 53-degree angle. Tan is opposite over adjacent. So that would be 8 divided by 6. And 8 divided by 6 would be a repeating decimal, about 1.33 repeating. Now down here is angle Y. If we find angle Y, it would be 90 minus 53. So angle Y is 37 degrees. And in part B, we want to find the tan of 37. And tan is opposite over adjacent, so that'll be 6 divided by 8. And that turns out to be a nice clean 0.75. Part C asks for the length of x, the hypotenuse. So we'll go back to Pythagoras. Leg squared plus leg squared equals hypotenuse squared. 36 and 64 add up to 100. That's x squared. So x is 10. Now in part D down here, it says go to the calculator and use the tan key to check your answers for A and B. So for the first part here, we'll do the tan of 53 on the calculator, and we get about 1.33. Yeah, pretty good. For tan of 37, we punch that in our calculator, and we get approximately 0.75. Yeah, good enough. Excellent. All right, in the second practice problem here, for each triangle, find the tan of each angle. So first we want to find angle P. Angle P is down here. So the tan of angle P is opposite 4 over adjacent 9. 4 over 9, I prefer fractions, but as a decimal, that would be 0.4 repeating. All right, now for part B, we want angle Y. Angle Y is up here. Tangent is opposite over adjacent, 6 over 8. Tan of Y equals 6 over 8. That looks familiar from the last thing we did. That fraction is going to divide out on a calculator. It'll reduce down to 3/4, or as a decimal, 0.75. And let me erase and move up so I have a little more room. There we go. Ooh, now here we get a double feature. First, angle L. Here's angle L. The tan of L is opposite 12 over adjacent 13. The other one is M. Tan of angle M is opposite over adjacent, just the reciprocal of what we found above. So the first, or this one, 13 over 12, is about 1.083 repeat. The 12 over 13 is about 0.923. And last one here. First, we're going to find angle B. The tan of angle B is 24 over 10. And that would be on the calculator 2.4. And now we're going to jump out down here to angle A. The tan of A is just going to be the reciprocal, 10 over 24, and that is about 0.416 repeating. Excellent. All right, in the last one, if you're when you measured these, if you had centimeters, I got here about 1.25 centimeters, and the bottom here about 2.5 centimeters. And then the bigger triangle, this side XY was about 1.9. XZ was about 3.8 centimeters. So here we were going to ask about angle C and Z. So here at C, the tan of angle C is opposite 0.125 or 1.25 over adjacent 2.5, and that reduces down to about half or 0.5. Now we're over here at Z. The tan of angle Z is opposite 1.9 over adjacent 3.8. Divide that on the calculator, you get 0.5. So the tan values are the same between these two angles on those two triangles. So what can we conclude? We can conclude angle C is congruent to angle Z. There we go. I hope this geometry video was helpful.